Best fit, and then the correlation coefficient. Okay, um, understanding really important stuff here is what we're able to do is we're able to model data. Okay, and we take that and then we can model a real-world situation. From that, we can create an equation that allows us to make predictions about a set of data and what might happen in the future, or if we did a certain number of things a certain number of times, what would happen without actually having to ever do that. Okay. So let's take a look here. A scatter plot is a graph that just relates two sets of data. We do these all the time. It's just a bunch of points on an XY coordinate, typically in the first quadrant. Okay. We can use a scatter plot to determine the strength of the relationship. That's what correlation means. Correlation is the strength of the relationship. Okay. Correlation, strength of the relationship. All right. I would write that down. The closer the data points fall along a line with a positive slope, the stronger the linear relationship and the stronger the positive relationship between two variables. So this is kind of self-explanatory. If the points are going down, then that's a negative correlation. The tighter they are together, the stronger. So these right here, these are going down, but they're more spread out, so that's weaker. This is just everything all over the place. Then there's a weak positive and then a strong positive. Pretty simple stuff. So, using a scatter plot, the table here lists a bunch of information, temperature and the electric bill for a given year, and then we plot these points. Okay. Describe the correlation. This is where you guys are going to have to put words together using grammar and punctuation to make a sentence. Okay. So as the temperature increases, the cost for electricity goes up, and the points are relatively tightly clustered, so there's a strong positive correlation between temperature and electricity cost. All right. So, this down here, the number of hours students spend online during the day before a test and the scores on the test. Make a scatter plot. How would you describe the correlation using the graph from problem 1? How much would you expect to pay for electricity? So first, let's make this scatter plot right here. Okay, so let's do this. Hold on one second. All right, so here's the table. Let's go number of hours online and then test scores. So let's put on the bottom here, we'll put hours. Okay. And then we can, this doesn't have to be fancy, guys. This is 5. Okay, that would be, let's go 4, 3, 2, and 1. And then from, we're going to go from 0 to 100. So 100's at the top. And then we'll just go 10, 20, 30, 40, 50, 60, 70, 80, 90. And then I'll move 100 down just a skosh. Okay? So then our scatter plot at 0, we have 100. And again, when you do these, you do as much of this that you need to. You know, if you need a little bit of practice making a scatter plot, then do some practice. 94, that was also at 0, so that's another one right there. Sorry, I missed my mark there a little bit. Let's see, we have one at 98, so somewhere right there. Another one at 88, so right there. 1.5 was at 92, so here. And you keep going and make your graph, okay? I'll keep going and make my graph. We can do this at the same time. There's 89. 2 is at 75, so 10, 20, 30, 40, 50, 60, 75 is right there. 2 at 70, so a little bit down. 3 at 78. Are any of these exactly perfect in the right spot? Absolutely not. They're a little bit all over the place, which is fine. Okay, it's fine for what we're doing, because what we're looking for is there a correlation? Okay, so there's what my graph looks like. Let's go back to the question. Question says, well, went back too far. Okay, so back up to the question and what it was asking. Make a scatter plot. We did that. How would you describe the correlation? So how would you describe this correlation? The easiest way to tell that is to give yourself a line, okay? If we were to draw a line here that went sort of through the points, I'd say the points are pretty tightly around it, okay? So I think we could say on this one we have a pretty strong, and it's going down. The slope is negative, so this is a strong negative, okay? Strong negative correlation. And then using the graph from problem 1, how much would you expect to pay for electricity if the average temperature was 70? So this is just a ballpark, like, give or take how much, just based on the picture, not doing any actual math. So go ahead and take a look at the picture here. If we go to 70 and we go up, that's somewhere in there, okay? So somewhere in the neighborhood of $160 a month. Now, is that exactly correct? No, but it's based loosely on the graph and the scatter plot that we have, all right? Trend line is that's the green line I drew in. A trend line is a line that approximates, and it's not bolded for you, but there you go. Trend line is a line that approximates the relationship between the variables or the scatter plot. We can use the trend line to make predictions. So up here, if you want to be sure, draw yourself a trend line and see if it goes through the amount that you picked. Does yours have to be 160? No, maybe you picked 155. No problem. Let's take a look at the next page. So writing the equation of a trend line. So what we're going to do now is we're actually going to take this trend line that we draw in, and we're going to pick some points off it so that we can write an equation. We just worked with point slope form and slope intercept form, so this should be pretty easy to do based on what we've already done. So let's take a look at this one. Literally, we make the scatter plot. We plot all the points. We sketch the trend line. You can work with somebody and have two different trend lines because the trend line is just an estimation, okay? It's important to understand that a trend line is an estimation, okay? It's just a way for us to give our best guess. So once we do that, we pick a couple points that look, not points that were given, okay? Look, you understand right here, 10 and 40,000, okay? 10 and 40,000 wasn't given, but it's about on the line. See, it was 40,100. So we're not picking points that were given. We're picking points from the line. We pick 2 points, we find the slope, and we know that the y-intercept was right here at 24,400. All right, easy enough. So then using that, we can plug numbers into this equation and find some sort of output. So let's take a look at number 2 here. The table shows median home prices in California. What is an equation for a trend line that models the relationship between time and home prices? Go ahead and pause the video right here. Try this problem on your own and then check it against what I have. Go ahead and pause the video now. Okay, so just checking in on your progress here. What we've done so far is I've created my graph, I've got my scatter plots out there, and I've got my trend line, okay? So if you're not to there, you got to at least get there. You're going to pause the video again. From here, remember, you're going to pick 2 points, find the slope, use those points to find the y-intercept, and find the equation of the line, okay? Go ahead and pause the video again and do that. So here's what I got for my equation. Again, yours might not be exactly the same. If you used 60 instead of 1960, you'll have different answers. If you used 100 instead of 100,000, you could have a different answer. I'll show you in a second an easy way to make sure your answer makes logical sense. But here's what I got. I found 4,000 as my slope. I didn't abbreviate any of the numbers or shorten any of the numbers. And then I ended up with y equals 4,000x minus 7,740,000. Now, if I want to know, does my answer make any sense? Because these numbers seem outlandish and you guys freak out when you get numbers that are big sometimes. Here's what I can do. I look at 1970. 1970 should be somewhere in between 100 and 150,000. Well, then let's plug 1970 in. So I can say 1970 times, I'm plugging it in for x, times 4,000. And I get that. And then I'm going to subtract 7,740,000. And I get 140,000, which falls in right in between there, just like I thought it should. So it's a really easy way to check to see if your answer makes any sense. If you're having trouble with that, let me know. We'll go over in class. Lastly, we can find what's called, one more thing, sorry, on that last page. The line of best fit is a trend line that is measured using a calculator. Okay, we can do this. So the line of best fit it's often called one method of finding it's called the linear regression. We can use the linear regression. Your calculator does it whether you have a TI or a Casio. It'll find linear regression. I'm going to show you how the steps to do it. You might remember it from doing it in Algebra 1 because we did the same exact thing then. If you didn't, I'm not going to go too in-depth into the calculator on the video. You're welcome to YouTube it. It's out there. And if that doesn't help, I will show you how to do it in class. Those of you who are holding out on buying a calculator, good luck doing this. It's going to be really, really hard. The correlation coefficient is called R. That indicates the strength of correlation. We want the correlation to be as close to 1 as possible. If it's negative, it's a negative correlation. If it's positive, it's positive. but the closer to 1, the more likely the line is going to be really accurate. Okay, that's really well said. I feel like a public speaker. All right, so your research. Here's the example. Here's all the stuff. You literally, guys, you just put it right in. This is on a TI. You put it in a stat menu on a. You hit like the stat button, and then it just does it. And in Casio, you go to menu, and then there's a statistics menu, and you put it in. It looks almost the same. You put this in, and then there is a way to find the linear regression, and it gives you y equals ax plus b, and it gives you the actual equation, and it gives you the correlation coefficient. So it's close to 1, so the line is fairly accurate. Not really complicated stuff here. Based on your model, how much do you expect to pay for a gallon of milk? You literally just take whatever you find and you plug it in and you solve. So no problem there. If we take a look down here, it says this table lists costs of 2% milk. Use a scatter plot to find the equation of the line of best fit. Based on your linear model, how much would you expect to pay for a gallon of milk, of 2% milk in 2025? So since the book shows you how to do it on a TI, I'm going to go ahead and do this problem on Casio. I'm going to pause the video right here. You should pause it too. Go ahead and put your data in, and then we'll look at what we get. So on a Casio, like I said, you turn on, you go to number 2 for the stat menu. I've entered all my data. The most common mistake with these kind of problems with students is data entry. Your fingers slip, I guess, and you put just the wrong number. So make sure you check your numbers that they're correct. From there, it's really simple. This REG, that's the regression. You simply hit F3. This is a linear regression. It's a line, so we're going to hit X just for linear, and then here's all your information. So this is what you're going to jot down. And actually, let's do... So 0. Y equals 0.93x, that's my slope, so that's right there. And then the y-intercept is negative 183.27. I went ahead and rounded it. The R is 0.906. That's a pretty strong correlation, just while we're looking at that. Let's go back here. So based on your model, how much would you expect to pay for a gallon of 2% milk in 2025? Well, the years where the X is, this was my domain, that was my range. So all I have to do now is, in my calculator, I'm going to take 2025, and I'm going to go just to the general run menu. I'm going to say 0.93 times 2025. I get that. I'm going to subtract. I have done something wrong. Yeah, nobody was going to say anything. I can't believe you guys were keeping that a secret. It's 0.093. Slightly different. Okay, so we go into our calculator, back to our run menu. And we have 0.093 times 2025. And then we're going to subtract 183.27, and the answer I get there is $5.06. I wouldn't put 5.055 because I don't know how you pay that in dollars. So the answer there is $5.06, based on the information that we have. All right? That's it for these notes. Bring your calculators to class next time. Make sure you don't forget them, and I'll walk you through how to figure out how to do linear regression in the TI if you still need help. Thanks. See you next time. Bye.
That's all, folks.